It's my great pleasure to introduce two Dutch heavyweights, Martine de Wit from Dus Architects and Joris van Tubergen, artist, superstar. Aren't you coming on the stage? Okay, so thanks for coming and enjoy the show.
Thank you for inviting us, Florian. Hello everybody, my name is Martine de Wit. I'm one of the co-founders of Dus Architects. And I want to tell you about the 3D print Canal house, but it's a research project, and I also think it's interesting to get you to know it. Yeah, better? Better sound. To introduce you a little bit to the office, because otherwise it's kind of strange as an architect to start this huge research project. We are Dus Architects, and what we do, we call it public architecture. Architecture that consciously involves in daily life, or actually that let you think about how we live on this earth and why we organize ourselves the way we do. And we do that by research and doing, so we really like to do. And one of these things is really in spaces, so we call it one-to-one architecture. But we also do the design of the process, so the people that work together with us, and we try to involve as much as people as we think are necessary to find the right solution for a certain problem. And if you think about that, also the program of the building, and then I'm not talking about data programming, but really the program of the building is something we would like to be involved to get a really specific solution for a certain problem. And I'll just introduce very fast some projects we did. This is a woods in the middle of the city, and from the outside it looks like this. It's only 4 by 4 meters, and if you go inside, there's a complete woods. And you can sneak out of the city for a moment. And that's also, this is only a month, but we do think that architecture could also just last for a night, or maybe even for an hour. This is one project we did in the middle of Rotterdam, which shows also the power of just doing it. We had this flyer got around on the internet, by Facebook, etc. And the day after, we had this small pavilion where we used street light as the main construction and the lighting, but also the electrical facility for the DJ. And because of using the internet, also a lot of people showed up, and we had a party going all night long while it was -5 degrees in February without any permission. So it also shows that if you make something really nice and it looks just, it looks like it looks, maybe you're, you get more done, let's say. This was a tribute to Buckminster Fuller. Buckminster Fuller is an architect who also looked broader at the way we live on this planet and how we could organize, for example, our raw materials and how we could distribute them more equally along all people on this earth. But what he didn't have, we do have, and that's the internet. And we really think that internet is gonna play a big role in, developing solutions for all the big problems. About this community-based making of this one real architectural project we did is a communal living area of 150 people, where we used really the community to make a new complex of 150 people living together during different stages of their lives, from when they got born to youngsters living together in a dwelling community, let's say, and elderly people with wheelchairs and people working, really living together, but they share at different levels, different facilities. And that's also how we like to work. So we work in a cooperation. with lots of different hoe zeg je dat? Companies, so, but not only architectural companies, but just really cross-sectoral working environment. And most of the projects we do also really together. And we did that because we see the multinationals are nowadays growing and growing. They get bigger and bigger. And you see the small, the people that work on their own without any employers. Yeah, that's it, payers. They get more and more, but the companies in between, well, you get less and less of them. So we said, how can we make a bigger company in this kind of world we're living right now, and how can we work together with these multinationals? And that's how we do it in cooperation. And it looks like this. And here you see also the Kamermaker. It's a silver tower. It's a printer we built, and it's in this picture. It's in the front yard of our office. So it was really open to public. Everyone could visit while we were printing. So as an office, we really try to find the newest solution for and use them in our designs. This is a bottle for Chanel fragrance number 5. It's also where we use 3D printing to make this one of a kind bottle. This is a silver model we did in 2010. It's a jewel we 3D printed in silver. It's a symbol of the moon to symbolize the digital world, where only the moon is still the physical part that connects all people on this world together. And we're working with materials. This is a project we are doing right now with potatoes, and we designed a potato which is based on the form of the potato, but also the material itself is only from potato waste from the fries industry. And we did it together with Color Fab, by the way. So, and they're standing right there, so I'm very proud. But as you can imagine, we had these Ultimakers already for a long time. I think the one in the right is one of the first Ultimakers ever built. And when we were playing around with these Ultimakers, we thought, why not print directly a house with it? If you can make a scale model, maybe you can also just print one-to-one. And that's how it started. We started to think, what if we can 3D print buildings? Can we then again introduce unique parts into the building industry, which is at the moment very hard? But also, can we offer global solutions with local output? So if we design something here, but we print it on the other side of the world. And what if we could use the knowledge of the community? For example, we used already the Ultimaker community for a long time, and I'm very happy now that we also meet in person today. But what if you can 3D print in plastic, and you can build your house from plastics, waste plastics? But the nice thing, of course, also is if you use FDM technique, you don't have any waste anymore, and the building industry is the biggest waste production industry in the world. So, thinking about all this, we thought, well, we just do it. It's also our way of working, so why not just try and start in building one? So we made a design for it, and we bought a shipping container on the internet via Marktplaats, eBay. And of course it should be movable, because that's the whole thing about 3D printing, no? That you can locally produce what you want to have, and you don't have any transport costs anymore, only for the raw materials. So this was in our front yard 2 years ago, the opening, but Joris will talk longer about making of the kamermaker and the technical details of the kamermaker. I will talk a bit more about this research project we are doing now for the Canal house, building the Canal house, which will take 3 years, and we started in March this year. So what do we have? We have a 2 by 2 by 3.5 print area, and we use a granulate extruder with a heated tube going down to XYZ frame. Well, and this was one of our first materials we used. It's a PP still. But why a canal house? Well, a canal house, last year we had 400 years of canals. And the canals were always a place for the newest innovations and to show off the newest materials and techniques that came from all over the world. But also because we are in the northern part of Amsterdam, and we thought, why not finish Amsterdam as a whole and try to 3D print the northern part of Amsterdam. But also, if you look at the Canal house, of course, they're all very unique, but still they speak the same language. And I think that's also some of the opportunities of 3D printing buildings, that you can make one template and modify every single house you're going to build to the site and to the personal freedom of the one who's going to build it. So we made a design with 14 chambers, and every room has its own research part. But since we launched this idea of printing a canal house, more and more people came to visit the kamermaker, and we've been on lots of television shows all over the world. And even Obama saw the 3D print canal house shown by the mayor of Amsterdam. So we started with the partners Ultimaker to make the printer, but now we have a consortium of lots of big partners working together with us on the house and really make this construction of the house realistic. So we defined 3 or 6 research and do's, because we still speak in research and do's and not research and development, because it's really a case study to find out what the possibilities can be of 3D printing for architecture. And one of them is building the kamermaker. We are now also developing a second one. The second one is developing a new material specialized for 3D printing on this scale, and developing construction methods of these rooms one by one. Thinking more in theory about what scripted or parametrical design can mean for architecture. And what if you have a digital file, how could you implement more smart ideas into the house itself? And if you take that even further, you can even think about scripting a whole city like this. And the last thing, our building site is an open museum, open for everybody, and everybody can visit us from Tuesday to Friday to see what we're doing. So it's an open research lab, let's say. So the kamermaker, I took it very short because Joris is going to tell more about it after me. But what we're doing at the moment, more or less, is updating it in the firmware and see if we can crowdsource the monitoring of the printer. The development of the material is mostly done by Henkel, what we are looking for is a strong, sustainable, and beautiful material, of course. But at the moment, we print with a hot melt. It's called. It looks a bit like this. But what you see is that the performance of the printer is really connected to the performance of the material properties, of course, and the material properties are again linked to the construction and the stability, and of course that influences the design again. And so this circle is an iterative process which we are doing, well, almost every week. And you see that we now have this ornamented facade with lots of triangles, just to keep it the outer shell as stable as possible. The more triangles you have, of course, in your surface, the stronger it becomes. Like I said, we are now using a macro melt. It's actually a glue. It's an existing biodegradable material. For 80% of bioplastics, and it's existing already for 40 years. And we are modifying this material to a material more suitable for 3D printing and architecture. But till now we used this material, and here you see the different coloring. If you use the black and but we are now. Here you see a photo from the top of a wall, which I can go back, no, go further. We print the house room by room. So the construction in itself, every room is a constructural entity. And we've printed now the first 3 blocks of the first room, so it's to get the stairs are integrated into the room, or into the design, into the prints. And every room consists of different parts. And in these parts, the construction, insulation, ducts and ornaments, so interior and exterior, are connected into one design. So we've now printed, well, this part, and it would be nice if by the end of the summer we are at the 4th part, so you know a little bit where we are at the moment. And here you also see the same part in the model. It's so nice that we can really use the same files and print them in the Ultimaker and then send them to the Kamermaker to print one-to-one. So here you see the part of the house with Inara in it, one of our employees. But it's really nice that this material, you can also have it translucent. So we could even think about integrating a lighting system, for example. So the house becomes more of a machine almost. And we're doing tests with insulating materials like mycelium. So it's funguses growing inside to make the insulating material, sorry. So we really have this dream about that in several years you would have a design as an architect of a room or of a house, and your customer is going to download it from the internet, change it according to their location and to their personal needs, and then print it. But you can also imagine that you choose different rooms together, put them together into your software, and then build it together as a house. And it's more or less how we see it, or how we think it could work in the future, or it already works a bit like this. But if you have a parametric design, you can have, for example, the purple field open to your customer, and the other parts keep the room constructually safe, and also your rules from your governmental area where you're printing in at the moment. So this is what I said. Really, we use the same file for Ultimaker as for the model as for the one-to-one print. But we do understand that at the moment, at least, not everybody can just start printing, and the printing thing is really a new craftsmanship you need to learn, and we have to learn also ourselves. What we do think is that it's important that educational programs already start to understand that they need to educate people in digital fabrication. And of course, we are not only printing a house, but also just some funny things. What I talked about, integrating smart things, we are now trying to find out if we use this faceted design of the facade. You can imagine that the top part, for example, has some sun energy paneling, and if you then change your house to another location or to with another orientation on the sun, your whole facade ornament is going to change to get most out of your sun paneling. And we're also thinking in that way about taking how you could collect water, for example, with your facade. And of course, if you would think about that in traditional ways of building, it would really be impossible to do that. But to get the water in, you never would like to do that. But because of the 3D printing ideas, it is already watertight. So it can be a possibility. And if you think about that with the scripting, I think if you would start, or if municipalities start to think about scripting new parts of the city and really base the design over new parts of the city on rules, this would be a more flexible future for cities where more temporary ideas and people can have the freedom to do for a certain time, or that it's more easier to change these ideas to according to the overall design that's still there. And we are now building the house here at this part. But I think there's a dwelling tower planned there. So we're also really doing that in practice and work that out together with the municipality of Amsterdam. So probably we're gonna change in 1, 2, or 3 years to location B. So like I said, our building site or construction site is open for public, and it's an exposition there. You can have a look and see how we're doing. It looks like this, where you can see the printer running every day, and inside we show you around of all how far we are with the different R&Ds. Now I would like to introduce Joris to tell more about the Kamermaker in specific.
Yeah, welcome. My name is Joris. I will give a short introduction. I will talk about the more the technical aspects and how it all started, because you just have to start. I'm a product designer, but I make installations with 3D printers, and I like to experiment a lot. And just because it's possible is a very good reason to do things. And this is how it started. It was only 4 years ago. So I think it was the first 3D print shop in the Netherlands. I just put my printer there and I start to make design where you can wait until it was ready. So I designed parts you can print in 4 minutes or in 10 minutes. Short experiments with printing chocolate in the shop. installations with artists. You could scream for 4 seconds and your cup will be created within 20 minutes. The installation is now running in the museum in León in Spain. I did some beeswax printing experiment. All these experiments were, most of them, there were like maybe 3 afternoons checking if it's possible and to get enough result to or continue or stop it or just put it on the shelf, and if you need it then you take it off the shelf again. And this was also very nice. It was a pop-up store in New York, and then I want to show that you really can do production with 3D printers. And the installation here in the blue, it's 12 machines. If you print objects for less than 30 minutes, you can produce more than 5,000 objects a week. So it's nothing to do with prototyping, that's more like production scale. And I think it's interesting that I can make it as a single person to make an installation like this. And I don't need millions of dollars to set up a factory. But so it's really about just do and see what's possible. Project I did last year to design a cup every week. But I want to talk about the Kamermaker and more also about the past 2 years. 2 years ago, the Kamermaker didn't exist yet. We had an idea. It's only 2 years ago. So it's really in 2 years from like nothing till what it is now. And this was the original idea. We had it on the drawing. And the print part was exactly an Ultimaker, but then times 10 in every dimension. And it started as at one of the community evenings. We have in the Netherlands every 6 weeks a 3D print community evening, and then people bring their machines and we start talking about it and then see who has enough knowledge to help us building the machine. And this is, yeah, so what are the possibilities? And then we just more or less started. You heard about the shipping container we ordered. It looked like this. A little bit different than the shiny box you see now on the picture. There was also a lot of work for that machine. And yeah, here you see already a bit more the shape of how it would look like. But that was the exterior part. And it's not just the printer. If you make a printer like this, you also have to make some sort of funding in the garden where it can stand, because you cannot just put it on the grass. There's a lot of things involved. It's not the printer and the mechanics. Martine told a lot about the designing process, all the architecture aspects, but also the connections with the city government. Are you allowed to make a house like this? You know, it's a lot more than just a technical thing. It's not just firmware, it's not just mechanics, it's just not printing. It's way bigger. And yeah, so, but at this time, yeah, we had the construction, and yeah, 3D printing is to move something in X, Y, Z dimensions and to place material. So the second part is see how you can place material on the right spot. So we looked into welding extrude. This is like for plastic welding. And the first question I had, if you want to print things this big, you should imagine 2 years ago we didn't have any budget. We were just starting because we wanted to make this. So we tried to find how can we do this with not so much budget. And then we think, okay, if you print something from 2 by 2 by 3 meters, you have to get it out. So it's not allowed to weigh more than 1,200 kilos because otherwise you need a forklift also. And so you want to print something around 200-300 kilos per block. Otherwise it's very difficult to handle without big machines. And then if you want to print something from 200-300 kilos, you don't want to wait for 6 weeks for that object. So I didn't check the speed of the machine. I just divided those numbers, and then we came to the conclusion we need to deposit 2 to 5 kilograms material per hour. Doesn't matter how you do it, you just need to deposit 2 to 5 kilos, and you should design it in a way that your object is not more heavy than 200-300 kilos. And then you can print something like an element this big in 2 to 5 days. So it's a complete different way of thinking of speeding up the machine. It's just like, okay, you can change it in the design, you can change it in the extruder machine. And these machines, they can produce like 1 to 2 kilo per hour. So it's getting in the right direction. And then just start experimenting. But at this time, we didn't have the machine yet. And I wanted to start with the experiments. So people who have an Ultimaker, they probably recognize the Ultimaker electronics. And we removed the stepper drivers because they're a bit too tiny for the bigger motors. So we put the bigger ones up there. And this is how we started. And we placed it on the milling machine we have in the lab at the Protospace, the Fab Lab of Utrecht. So we don't use the CNC controllers from the machine. I just hooked up the Ultimaker board and see what's happening. And these are like the very first test. Kamermaker is in beta stage. This is like the pre-beta stage. See what's happening. Yeah, and for me it was already funny that you could use the same workflow as regular 3D printers for a big machine like this. And that helps because I'm product designer, I'm not so technical, not a programmer. I want to have the same workflow because then I can also get the knowledge of more and more people who wants to help us with the things. And this is interesting for me. This is really interesting because if I know if this works and I maybe spend 2 or 3 days on it, then I know if I spend a month on it, it will be better. You know, and if you cannot make it work in 1 or 2 days, you never know what you get in a month. So it's very important that you get a result, at least a result, in a short amount of time. Well, the welding extruders, they were a little above our budget at that time. So I was experimenting with the regular extruder mechanisms, but I thought, okay, with one single filament, I could not go more than 200 grams per hour. So if I have 3, then I come to 600 grams per hour. So the first experiment was just filament printing, but then a lot more than the regular. I think normal 3D printer prints about 30, 40 grams per hour if you speed it up a little bit, but then it stops. And here we made some tests and we could come up to 500 grams per hour, so that's already a lot more. And then the first humans got printed and sheep. And at this time, we already started, and that attracted a lot of people, and also people with the knowledge of extruders, with the knowledge of mechanics. You know, because we started, it attracts a lot of people, and then the guy from extrusion, they make granulate extruders, and this is a very, very, very small granulate extruder. It's like on the low range of granulate extruders, and it can only produce 10 till 20 kilos per hour. That's like the low range of granulate extruders. And we wanted to have something between the 2 and the 5. So we have to run. But it's nice that you have these connections. So we did some tests. You already see here a heated hose connected to it. And this was with a robot company who got also interested. And we did some tests first with a robotic arm and put the print head on it. And then just see if that worked as well. Then the printer was installed. So we had to mount everything, and you need some extra pieces. So we printed parts we needed for the Kamermaker with the Ultimaker. So we printed them and could mount the end stops and other things up here. And then we start printing. And this was actually 1 day before the opening of the site. That was 1.5 years ago. And the guy from the extruder company, they borrowed the extruder for 3 days for the opening, so we could print with a real granulate extruder. And this was the outcome of the first, very, very first prints. And the next day, it was crowded like this, so we had to show how it should look like. And there's a lot of people interested. We also had a lot of 3D printers for explaining the process. Yeah, if you can see it in small, and then you can do it the same. Maybe a short sidestep, because it acts exactly the same as an Ultimaker. You can have the benefits of all the firmware upgrades. You have the benefits of all the site parameters. I don't know if you know the program Doodle 3D, but you can draw something on the iPad, hit the print button, and it gets printed on your Ultimaker, or on a MakerBot or whatever 3D printer. We can actually hook it up the Kamermaker as well. And you can draw something on the iPad, hit the print button, and it will be printed on this machine as well. I think that's really interesting. And the same is for driving it. I think 2 years ago you needed, it was still print run to drive a machine like this. At the moment, we run it from an iPad with Octoprint. Yeah, it's possible because people are willing to make these kind of applications if a lot of people can use them. Now, not many people have a camera marker like this, but a lot of people have a 3D printer, and they want to develop it and make it better. And our task is to convert all those benefits into a large-scale printer and have all the benefits. So it's also running better, like regular 3D printers. And this is how it was printing during the opening. And for me, I'm involved in the technical parts of more the printing parts of the printer. It's really interesting to see that you have exactly the same problems on the small scale machine. Everybody heard about warping, and everybody heard about that the layers are not touching or whatever. It's exactly the same, but then 10 times bigger. But if you cannot solve them on the small machine, it's really difficult to solve them on the big machine as well. If you can solve them on the small machine, you can also solve them on the big machine. And that's really interesting because you cannot cheat with this. So you're also allowed to not cheat with the design. You can really do the testing in the small scale and see how it works on the large scale. And I really like that's in public space, so like everybody can see what can be printed. And these were the very first prints where you can actually see an object in it. And because it's so in public, this was also during the opening, it attracted a lot of people. And out of the blue, a person came and he brought this granulate, and it was filled with 60 or 70% of wood fibers. You know, you don't have to search for the information. If you spread the word, also people are coming to you and bring information. And that's really interesting. And also the project is, it's really, a lot of people get attracted to it. And from children. And I think it's only one of the few 3D print projects which is featured on Hackaday and at the same time in Vogue magazine. I don't know many 3D projects which is such a broad range of media attention. And that's also, what is it? It's too much. It's not just 3D printing, it's not just the social story or the architecture story, it's like everything combined. And then people are, just come and see how it works. And at this time we were still printing with the DIY extruder, because that was available. And as Martine said, now we have a lot more partners, so you can also co-create and cooperate with them. And we start design our own extruder that should fit the needs for our printing process. And also the electrical schemes, how to make it, but again, make the electrical schemes based on or Ultimaker boards or the same Marlin or Sprinter or the same firmware as normal 3D printers, because then you don't have to redesign or design your own updates. No, the updates you can implement them from other people. This was, in short, the technical implementation of the past, from 2 years till now. It's really going fast, and now we started printing. And because the printer is now working, it's very difficult to get the knowledge and also implement the knowledge of the small-scale printers, because the mechanics are more or less solved. The printing process, there's a lot of research to do for it, but it's more difficult to involve the small 3D printer community in that part. And what I would really like to do is not asking them to help with the printing process, but help them for maybe monitoring the print. So crowdsource to help the print team so they can work on new designs and new features, and try to open up the whole building site and the printer so everybody can log into the website and see if the print process goes well. And if you can do that with the community, maybe if 200 people are watching the process and one says, oh, something is going wrong, then you get an email or a notice that you ignore it. But if 10 people say there's something wrong, you get an email. And if 100 people say there's something wrong, you get an SMS. And if 200 people say there's something wrong, maybe you shut down the system. You know, so they really can help in monitoring the process. And if you have that set up very well, then you can print 24/7, much easier, because you only need one operator, more or less nearby, not even on the spot, just nearby. And then everybody can help also to promote the project and make it bigger. And there are a lot of things you can combine, and also, yeah, the screen of Octoprint here as well. But you can also use the webcams, and there are a lot of more things how to involve the community. And these were things that was impossible to implement 2 years ago because we were too busy to get the technical aspects done. But I think for the next half year, it would be really interesting how to open up this part so everybody can see what's going on. I think there's also a small time-lapse movie of the printing process. And also technical aspect, it's not exactly the Ultimaker on 10 times bigger, but it still is not also the traditional way of moving XYZ frame. We use a H-bot frame, so you have the motors controlling the XY system are not moving, so they're fixed in the place, so you don't have the weight of the motor transporting. It's more the technical part of it. And that's also in the mind of how Ultimaker works. So they also don't transport the motor. You don't have to move the X motor. You don't have to move the extruder. So you make it more lightweight. So it's also a less dangerous machine. You actually, if you're working with this machine, you're standing inside the printer. You're standing inside the XYZ frame. And that's an interesting experience to work like that. And yeah, that's the... What? Oh, yeah, I don't know. I tried to set up the screens for the webcam. Yeah, this is actually a live connection with Amsterdam. And I think we can also see if they're printing or not. I don't think they're printing, but you can control the machine. I think this is the part where you can see if there's material in the feeder, but there's no material. So we should have a button here, say alert, there's no material in there, and then I hope somebody can control or stop the printer. That's the short, yeah, behind the scenes talk about the 3D print Canal house. Next. Yeah. So if there are any questions or technical or maybe more social or architecture questions, please ask them. If you don't want to say them in English, you can try German, and then I think I understand. Free. I know them free. In the back. Wait, he has to open it.